This is Showman from Oil and Gas Field Quality Control. What is pigging? I have one specific video for that, where in general I have discussed the pigging. And what is smart pig? Also I have one video which is also named as caliper survey. But today I will discuss another higher level of smart pigging, which is using magnetic flux leakage technology, in short MFL. This is used as a part of inline inspection technology. Caliper survey only measures the internal dents in the pipeline. It is only measuring the ID, whereas this MFL using this magnetic particle inspection technology to detect even the thickness, subsurface and surface defects other than the internal diameter. So let us start. Here one thing good to know, pig doesn't mean any animal what we are thinking. This pig is actually pipeline inspection gauge, PIG. What is MFL? Magnetic flux leakage or MFL detection is one of the most popular methods of pipeline inspection. It is a non-destructive testing technique which uses magnetic sensitive sensors to detect the magnetic leakage field of defects on both the internal and external surfaces of the pipeline. Magnetic flux leakage technology is widely used non-destructive technique method for the detection of corrosion and pitting of steel structures also. MFL provides a cost-effective and high-speed inspection of tank floors. The working principle of MFL. MFL probes incorporate a magnetic detector placed between the poles of the magnet where it can detect the leakage field. During inspection, a magnetic circuit of shorts forms between the part and the probe. The magnetic field induced in the part saturates it until it can no longer hold any more flux. The flux overflows and leaks out of the pipe wall, and strategically placed sensor can accurately measure the three-dimensional vector of the leakage field. Because magnetic flux leakage is a vector and that a sensor can only measure one direction, any given probe must have three sensors to accurately measure the axial, radial and circumferential components of an MFL signal. Let us discuss the four simple steps of MFL and detection. The first step is magnetization. A powerful magnet, either permanent or electromagnetic, is used to induce a strong magnetic field into the ferrous metal being inspected, saturating it with flux, magnetic flux. Flux leakage. Where there are defects, this flow of flux is getting disturbed, and like corrosion, pitting and metal thinning type of defects, the magnetic field leaks out of the material. Then the detection stage comes. Magnetic sensors placed in the poles of the magnet detect these disruptions in the magnetic field. Finally, the mapping. These detected changes are displayed on a digital screen, providing a real-time map of the defects within the structure. The both schematic sketches displayed in this slide, you can see what I am saying. You can relate with these sketches. Application of MFL. Basically, MFL are used in not only in the pipeline, but it also used in the storage tank floors, a primary application to identify corrosion and material loss. In the pipelines, before we were generally using caliper survey, and nowadays it is the operations or proponent or pipeline owners, they need more information. So instead of caliper survey, we can use these MFL pigs used for inspecting both internal and external surfaces of the pipeline for defects. It will also give you the internal diameter, any dents or anything, whatever we are already getting in caliper survey. So MFL is more productive and giving more informations in a cheaper price. Heat exchangers and tubes, effective for detecting flaws in ferromagnetic tubes and ascending wall thickness loss. Bridge components applied to structures like girders and cables to ensure structural integrity. Benefits of MFL. Detection of surface and subsurface defect. MFL technology excels at identifying both surface level flaws like cracks and corrosions and subsurface defects that are not visible to the naked eye. So as I told you, this is a magnetic particle inspection. So if you know one of the popular NDT method used for the welding, so that is MPT or MPI, magnetic particle inspection. So it is the same technology, similar technology, so you can relate if you compare with this MPI. High speed inspection. MFL is a fast inspection method suitable for large areas such as tank floors. Detection of defects. It reliably identifies various defects including corrosion, pitting, grooving and cracks. Non-destructive. The method does not damage the material being inspected, allowing for continued use of the structure. Cost effective. Helps prevent costly damage and structural failures by identifying potentially problems early. Versatility. MFL equipment can be adapted to inspect a wide range of ferrous material and structures including pipelines, storage tanks, rail tracks and automotive components. Let us discuss the limitations of MFL. The major restrictions or limitations of this MFL, we can say it is only effective for ferromagnetic material like steel. Non-ferromagnetic material like stainless steel pipeline, it will never, austenitic stainless steel never attracts magnets, so it cannot be used there. Surface condition. Tank floor inspection requires preparation to remove scale, dust and debris for optimal result of this MFL. Complex geometrics, it cannot work in the complex shapes like lap welds or when dealing with significant obstructions. Difficulty in detecting the smaller cracks. It often overlook or cannot detect the a range of defects. It can struggle to detect very small or fine cracks. Operators expertise. How you interpret the result, it is important because it needs operators expertise. Effective MFL testing relies on the skill and experience of the operator. Proper training is essential to interpret the data correctly and to identify defects accurately. Otherwise, maybe one acceptable area with a lack of knowledge, we may misinterpret. There are some other names which is also used to call this inspection, but all are same, like MFL testing, MFL inspection, magnetic flux leakage inspection, flux leakage testing, magnetic leakage field testing, magnetic flux testing, leakage flux testing, all are same. Types of MFL equipment generally being used in the industry. First one is the handheld MFL scanner. These are portable device. These tools are used by operator by manually scan areas like to scan welds, joints or small section of ferrous material. Due to their portability, these scanners are particularly effective for spot inspection like spot inspections for storage tank, pipeline and structural steel components. Inline MFL tool. This is the popular tool which actually the purpose of this video today. Inline magnetic flux leakage tools are often referred as smart peaks, are used for large scale inspections of pipelines, kilometers of pipeline. These automated tools are inserted into pipeline and travel through them, conducting a comprehensive inspection of the pipeline interior. The tools generates a magnetic field and detects any magnetic flux leakage caused by defects in the pipeline wall. Okay, tank floor MFL scanners. The tank floor scanners are specialized pieces of equipment designed to inspect the floor specially for the large storage tanks. These scanners are critical for detecting corrosion of material thinning at the bottom of the tank where liquids and chemicals are stored, and this is the one of the most vulnerable areas for corrosion due to contact with the stored substances. Rail inspection for MFL devices. Rail inspection for MFL devices are used to inspect rail tracks and other critical rail components for flaws that could lead to accidents or service disruptions. These devices are typically mounted on rail cars or specially designed inspection vehicles that scans the tracks as they move along them. By identifying defects such as cracks, corrosion, or material fatigue in railways, rail inspection MFL devices help ensure the safety and reliability of rail networks. Automated MFL systems are integrated into manufacturing lines to inspect steel plates, pipes, and other ferrous component as they are produced during production, you can say. These systems are typically stationary and operates automatically, providing real-time inspection data to ensure that product meets quality standards before they are shipped or used in critical applications. Now, the broader applications of magnetic flux leakage and testing, there are four major industries like oil and gas industry, transportation industry, manufacturing industry, and power generation industry. But we will focus here for oil and gas industry only. In oil and gas, we are generally using it in pipeline integrity monitoring, tank inspection, and offshore platform inspection. So MFL plays a crucial role in identifying defects that could lead to leaks like ruptures or catastrophic failures. MFL is often used in inline inspection tool when it is termed as smart peaks like caliper survey to inspect long stretches of pipeline from the inside, ensuring safe operations. We are taking here one sample procedure, or I will mention some specific tool names, their acceptance criteria, their calibration criteria, but all are for education purpose only. My intention is not to copy or steal some others procedures and share it to you. It's not like that. It is only to understand the technology. So take it only for the education. MFL examination and acceptance criteria for the pipe portion is according to the API 5L, because we know the pipeline materials are we are using in Gulf is basically API 5L. MFL is being used to detect longitudinal and transverse discontinuities in the base metal on both the inside and outside surfaces. So inspection will cover 100% pipeline length except the 300 mm on each end. It will be not covered by this equipment. For a practical example, let us consider a pipe diameter range we have is 4 inch to 18 inch. I will tell you one tool. This tool can cover 4 inch to 18 inch pipe diameter, and wall thickness it can detect up to 5.4 mm to 57 mm. It will not only detect surface, it will also detect subsurface, generally 6 mm subsurface. So if your thickness is 5.4 mm, it practically or virtually it can detect the whole thickness, any types of defects. Reference international standard for the acceptance. As I told you, API 5L is used to get the acceptance standard for the line pipe, how much dent is acceptable, how much defects or porosity or pipe defects are acceptable. And ASTM E570 we are using to follow the standard practice for flux leakage examination of ferromagnetic steel tubular products. ISO 9712, it is for the NDT qualification and certification of the personnel. Okay, so now how to qualify the personnel for this MFL? Personnel involved in NDT inspection shall be qualified in accordance with ISO 9712 as I mentioned just now. Level 1 personnel may set up and standardization NDT equipment and conduct the inspection. Level 2 personnel will be responsible for the interpretation. So level 1 may perform the job, and level 2 can interpret the result, data, and final reporting. So level 2 and 3 personnel are required to have passed a visual acuity and color contrast eyesight test. Okay. Equipment and accessories, again, it is for a sample. It is not a advertisement or kind of disclose anybody's procedure. So equipment manufacturer, here is US Tuboscope MFL 2.5S, one popular company, and Jar Forester MFL 310. So there are two types of machine. One is analog, which is for longitudinal inspection. It has twin probe rotary inspection apparatus, 16 coils for each probe, and each coil is 12.5 millimeter in length. Okay, then sonoscope is for the traverse inspection. 8 fixed probe inspection apparatus are there inside, and the layout of the probe is circumferential, which covers 360 degree. All the equipment shall have a current calibration certificate. Calibration period shall not exceed 12 months. Equipment has a capacity or capability of auto online paint, one color marking for any indication exceeding the reject threshold allowed. So the defects will be marked with one color paint. We need to prepare the reference pipe or calibration standards pub piece, from where we will initially calibrate the machine before the work or during the mock-up or demonstration for client's approval. Okay, the material of this reference pipe should be the same. It means the pipe selected for the reference standard shall be free of any type of natural defects which will not affect the calibration. We need to test it before to check there is no natural defect. The reference tubes shall have the same specified diameter, thickness, and same surface finish and delivery condition, as rolled or normalized or quenched or tempered, which exactly your pipeline is having. So you just cut a pipe from your pipeline excess material. Notches dimension. So we need to create some artificial defects. So notches dimension, orientation, and acceptance level shall be conducted in accordance with ISO 10893-3 para 6F2. Notches shall be 40 mm in length and 1 mm in width. I have a photo of the notches, their locations, their dimensions and positions, etc. In the next slide. Notch depth is 5% of wall thickness, but with minimum of 0.3 mm. Longitudinal notches orientation shall be parallel to the pipe axis. Traverse notches orientation shall be perpendicular to the pipe axis. Shall be also ISO 10893-3. So this is the reference pipe or calibration standard pipe is drawing. You have to prepare the pipe artificial defects accordingly. Test surface condition. What is the minimum requirement of the surface preparation before the test? All scanning surfaces shall be free of loose scale, rust or other extraneous material. The surface shall be sufficient uniform contour and smoothness to allow satisfactory probe or sensor contact. Okay, technique. You can see analog longitudinal inspection machine. I have a schematic diagram here, and you can see the name of the where the transducers or sensors are located, and ID defect, OD defect, whatever it can detect, it is already written in these two pictures here. Okay, so the coil of wire passing through the diverted flux will have a voltage generated within it. The amount of voltage will depend on several factors: the angle at which coil cuts the flux, the density of the flux, and the velocity of the coil with respect to the flux. If the angle of the coil and the velocity are kept constant, the voltage in the coil is proportional to the density of the flux, an indication of the severity of the defect. So more dense the flux is an indication of the severity of the defect. The detection of the OD, outside diameter, and ID, internal diameter flaws. Flaws on the outside diameter of the tubular product will have a different flux diversion characteristics with respect to the detector on the OD surface than those located subsurface or the inside diameter. You know, the density of the flux here is very much important to to judge the severity of the defect. The flux diversion for an OD flaw emerges with a sharp rise at the surface. Since an ID flaw is further from the outside surface, its flux diversion emerges at the outside surface with a longer gradual rise of lower intensity, as shown in figure. As we told, no, it needs operator skills and experience, not only training. He should have some practical experience before he independently interpret a result. So the detector coil intersects the flux diversion of the OD flaw for a short duration, generating a voltage with a high frequency. It intersects the ID's flaws, more gradual flux diversion for a longer period of time, generating a voltage with a lower frequency. The system has a capability to independently vary its sensitivity to OD flaws versus ID flaws. The system electronics discriminates between the frequencies of OD and ID flaws by separating them into separate circuit. You can go through the sketch while you are listening to the explanation. It will be easier for you to understand. Okay, pipe to be inspected will pass through the inspection apparatus to determine defects oriented within the pipe. Longitudinal discontinuities conduct the examination employing a transverse magnetic field and MFL detectors. Transverse discontinuities conduct the examination employing a longitudinal magnetic field and MFL detector. Sensitivity. Ensure the equipment like sensor, magnetizing pole, etc. are set up properly to receive the reference standard. Okay. There are calibration different types. One is static calibration, dynamic calibration, and there will be calibration also before we start the examination or the actual MFL detection. Static calibration has two types: longitudinal calibration and transverse calibration. During longitudinal calibration, you can set the alarm gate value at 50% FSH, set the throughout speed to 0.03 meter per second to 0.05 meter per second, and the process the reference standard. If you run in higher speed, there will be a chance of skipping the defects. It can overlook the defect, it cannot find the defect. So you have to be exactly within this manufacturer's recommended speed range. Activate the calibration status and continue to process the reference standard to ensure that each channel produces a signal of 50% FSH from the same artificial defect. Transverse calibration set the alarm gate same at 50% FSH, set the throughout speed of the process and the reference standard. For example, 250 mpm rolling mill tuboscope MFL 2.5S, the model we are discussing, the throughput speed is 1.3 to 1.8 meter per second. Activate the calibration status and continue the process the reference standard to ensure that each channel produces a signal of 50% FSH for the same artificial defect. Dynamic calibration. Process the reference standard with artificial defects at the production speed, ensuring that inspection coverage is 100%, which does not include the uninspected end area, which is 300 mm from the end. I told you before. For calibration, the reference standard shall be processed 3 times to ensure that the artificial defects have been repeatedly detected at equal to or greater than the reject threshold level. Okay, the paint marking system shall be initiated on the 3rd run of the dynamic calibration to validate that the marking system is functioning. Wherever there is a defect, I told it will mark one color paint for you at the defect locations for easy recognition later on. All paint marking shall be removed from the reference standard after validation for the next lot of calibration. A dynamic calibration report will be generated and signed by level 2 or level 3 person responsible for MFL testing. On the printed dynamic calibration report, the stamp will include the following information as a minimum: testing speed, rotation speed, reference standard number, acceptance level, equipment operator, qualification level, confirmed time and shift. Calibration standard for examination. So the equipment shall be calibrated under the following conditions. Start of shift periodically every 4 hours. So we need to do calibration when we start the work or start the shift, and then every 4 hours we need to again repeat the calibration to make sure that the machines has no issues. Replacement, when you replace the operators you need to calibrate. Replace the transducer or diameter, anything you need to calibrate. End of the shift, when there is no subsequent shift also you can calibrate the machine. Anytime there is a negative calibration coming, you notice some kind of negative calibration, also you need to calibrate again. If any anomaly with respect to the equipment function is identified, then the reference standard shall be processed, and where the equipment is found to be out of calibration, then recalibration shall be performed in accordance with this procedure, and all pipes since the last valid calibration shall be quarantined and re-inspected. Every 4 hours each shift shall check the residual magnet field on both ends of a pipe at 0 degree, 90 degree, 180 degree and 270 degree. The value at any position shall not exceed 25 Gauss. Gauss is the measurement of the flux, the unit, and the average shall not exceed 20 Gauss. If the residual magnetism excessive 20 Gauss, then the pipe shall be demagnetized again. All pipes since the last valid demagnetization check shall be verified and either accepted or demagnetized depending on the value found. Inspecting speed shall be kept identical speed with dynamic calibration when inspecting normally. Imperfection evaluation shall be performed. Evaluation and interpretation of the imperfections. These shall be performed by NDT level 1 certified inspectors under the supervision of NDT level 2 or level 3 certified inspector, or by NDT level 2 or level 2 certified inspectors by themselves. For an indication which is less than the reject threshold, the pipe shall be deemed to have passed this test. For any imperfection which is greater than or equal to the reject threshold shall be evaluated. According to the dynamic waveform graph, judge the imperfection whose indication greater than or equal to the reject threshold is on the inside or outside surface. If the imperfection is on the internal surface, then dispose it in accordance with the point 11 described in next page. If the perfection is on the external surface, perform visual inspection on the full circumference of the pipe where there is an alarm. If there is a visible discontinuity, then dispose it in according to the point 10 I discussed in the next page. If not, then reprocess the pipe according to this point 3. When no imperfection is found in the area of interest, then the pipe shall be re-inspected full length using the same inspection method and the same sensitivity. If no signal is obtained equal to or greater than the reject threshold level on re-inspection, then the pipe shall be acceptable. If signal obtained equal to or greater than the reject threshold level on re-inspected, the pipe shall be rejected and the area containing the defect shall be cut off within the limit of required length. Now, how to do the disposition of the imperfections? Pipes containing external surface defects shall be disposed as one of the method I will be discussing now. The whole circumference within 100 mm area of containing imperfections shall be inspected by visual. If there is a visual defect, then grind it and until the defect is removed thoroughly. The grinded area shall blend smoothly into the contour of the pipe. Then check the remaining thickness is within tolerance or not. The pipe shall be retested as previously specified. If there is no indication equal to or above the threshold, the pipe shall be passed the test. Even after grinding, if there is an indication equal to or above the threshold, then the pipe shall be rejected. The section of pipe containing the defect shall be cut off. The pipe shall be rejected. Pipe containing internal surface defect shall be given one of these disposition I will tell you now. The section of the pipe containing the defect shall be cut off 100 mm from the imperfection towards the middle part of the pipe, and the pipe shall be retested. If after 2 consecutive tests no signal are obtained equal to or greater than the reject threshold level, the pipe shall be deemed to be acceptable. Otherwise, the pipe shall be rejected. So this chart here is for just a sample educational purpose only. You can see there are two types of run. The first run was for ABCDE one line, whatever the line name, and it is a 5.6 kilometer long line. First type of run is gauging. The flow range is 200 to 275, and pressure we put 620 plus minus 10%, and the velocity as per the manufacturer recommendation was 3.5 meter per second to 5 meter per second. The duration of run was 2 hours. And in the second case, we run the MFL tool. Here also the flow range almost similar, 200 to 350, pressure is the same, and the speed is little bit higher, 3.5 to 6.5 meter per second, which has speed control unit into the tool, and then duration of the run is 3 hours, and it is optional. I mean, if it is required MFL, then we do, otherwise we can do only the gauging. For the second line also you can get a comparative comparison here. This line was 35 kilometer long, and the type of run was gauging. Then the flow range was 200 to 275, pressure is 620 plus minus 10%, velocity for during the gauging it was 3.5 to 5 meter per second. It took 8 hours for the run. MFL took a little bit longer, 10 hours. Data is almost the same, only the flow range is a little bit higher, 200 to 350. But you know, this the tool itself has a speed control unit, that's why it is called smart peak. So guys, this is the end of this MFL induction video today. Hope it gives you a good idea. If it helped you to increase your knowledge even a bit, please don't forget to hit the like button and share my channel to your friends so that they will be educated too, and I will be inspired if my subscribers are increased. Signing off for today, Showman.